commensurate with reality. I mean, it's tricky. A thing about power law distributions is that they're pretty natural, and sometimes they might seem um, problematic if you have too much voting power associated with them. But, one of the things that's important to remember is that this is a measurement, and therefore it is, to the best of its ability, meant to represent the real contributions. And then how we convert those measurements into decisions is another point where our policy choices affect sort of representation. So things like conviction voting, things like quadratic voting create different ways of funneling the measurements that represent people's ability to participate into decisions. And I think that's one of the reasons it's so interesting to think about this in what I would consider an electrical engineer's mindset, where signal processing is the given analogy for voting, where you say, look, like there's this base level information or even capacity to provide information. You could think of it as gains on your inputs. Each individual in the community has their own input signal to provide, some measurement of their impact hours, or their sort of TEC tokens post-launch is effectively the gain parameter on the input of their opinion. But then there's a lot of downstream signal processing that's very context dependent, that's meant to effectively synthesize that into decisions. And depending on what kind of decision you're making, you might want very different structures for that. And obviously we've done a lot of work with conviction voting to make it effective for certain kinds of funding decisions, tested it out quite a lot with OneHive. But it's also keep in mind that there's a lot of research going on in different ways to do this, and at least for me, the framing of this as signal processing, as sort of this sensor fusion where each individual person is a sensor and these weights are gains, but we still ultimately need one sort of community level decision, actually makes a really powerful analogy and helps us explore not just what the right algorithm is, but actually what's the right algorithm for the right kind of decision? Like, what is the way in which we synthesize this? And actually, to Trent's question earlier, the answer largely depends on what your objectives and constraints are. And so there's still a lot to be learned, but at least, again, my take on this is the token engineering community is in a sort of privileged position to explore these algorithmic policies for policies that result in good signal processing, which result in coordinated decision-making that they feel is representative of them, even when they don't individually agree on everything.
Yeah, I would love to talk second order